All right, welcome everybody. Let's do this. So, the hunt for a better notation. Let's look at the learning intention real quick. Students represent the linear transformations of the form Lx comma y is equal to ax plus by comma cx plus dy by matrix multiplication. So you're looking at this, you're like, oh boy, what are we getting into? But this is going to be the new idea of what is a matrix and how do we multiply it and how does it make a connection with the linear transformation. So right now, we don't know any of this, but just give it some time, okay? So have this as your learning intention, and the do now, what I'd like you guys to do is, let's say if you have some L1 and it looks like this, and you have some L2 and it looks like this, I want you to evaluate L1 at 1, 1, at 1, 2, 1, 1, 1, 2, and if you're thinking, Mr. G, what on earth are you talking about? Let's do one example together. So if we look at the first one over here, let's look at L1. Let's see this. So here, we know our L1 is equal to this formula. Here, this represents my x and this represents my y. So what am I going to do? I'm just going to plug this 1 for x and this 1 for y into here. So I know L1 at 1, 1 has to equal to, here, what's my x value? It's 1. So I'm just going to substitute 1 in here. So it's 2 times 1 minus 3. What's my y value? My y value is 1, comma, and I forgot the parentheses here. 3 times 1 plus 2 times 1. Okay? Just take a second. All I did was substitute x for 1 and y for 1 into this linear transformation. And then let's solve it. So this is equal to what? 2 times 1 is 2, minus 3 times 1 is 3, comma, 3 times 1 is 3, and plus 2 times 1 is plus 2, so then this is equal to just 2 minus 3 is negative 1, and then comma 3 plus 2 is 5. And this is a point, right? So if I have my point 1, 1, right? This 1, 1 changed to a negative 1 and comma 5. So this point went from here to here, okay? And that's all this is. So what I'd like you to do is try and do it for this L1 at 1, 2, at 1, 1, and at 1, 2 for L2. Okay? Once you have all that, the idea is, what if I were to tell you there was an easier way to calculate these solutions that you got over here? Okay? Actually, let me pause the video. I didn't do the let me do the calculations real quick. Have the same thing. Okay, so what if I were to tell you that there was an easier way to calculate these solutions? Wouldn't that just be the coolest thing in the world? Let's get a thumbs up from our president that that's the coolest thing in the world. And so in the mid-1800s and through the early 1900s, these types of formulas kept popping up in math, and people were struggling for a simpler way to work with these expressions. So mathematicians used a representation called a matrix. What is a matrix? A matrix is a rectangular array of numbers that look like this. So just by looking at this, you're thinking, all right, I still don't understand what a matrix is, and that's fine. But it has this look to it. So let's observe the following. We just had this calculation for L sub 1, right? We calculated this, right? And we got, when we plugged in 1, comma 1, into this formula, we got negative 1, 5, and that was done, where was that done? Let me just check real quick. We just did that right here, right? During this calculations, we got negative 1, 5. And what we're gonna try and do is we're gonna try and do a matrix multiplication to get the same solution here. So what I'd like us to first look at is, just take a look at this. If I have here, like this L1 xy, it was equal to this, right? So instead of representing this like this, we're just going to represent this like this, okay? And instead of having it like this, we're going to just make it look like this. So then these two are going to be the same representation, okay? So once we have this, let me show you how to do matrix multiplication. And it will look something like this. And if you're thinking, what on earth is going on? Just be patient, okay? So what I'd like you to do is, first don't freak out. I want you to follow me, all right? So take 45 seconds and just write this down in your book. And then we're gonna go step by step on how to do this multiplication and where did I get these numbers from, and how is there a connection from this to this. And if you want, you could pause the video and maybe you'll see something. But yeah, okay. So now that you have this in your book, let's begin. All right, so the first thing we want to do is we want to follow this. Like, this is our kind of guideline here. This, whatever this thing is that we have going on here. All right, this will be some matrix multiplication. So let's take a look. First, we want to calculate a times x. So here, if this is my matrix up here, you see I have 2, -3, 3, 2 at 1, 1. My a value is going to be 2, and my x value is going to be 1. So what I'm going to do is I'm going to do this 2 times this 1, all right? So just take your time. Notice that this is my a, which is 2, and then this is my, let's see, I'm going to do 2 times, right? Because this is a times x, I'm doing 2 times the 1 and the 1. So I'm doing 2 times 1, and what do we get for that? That's just going to be 2. And then what we're going to do is, once we have the a times x, which is 2 times 1, then we're going to do b times y. Now here, where is my b? My b is -3, and my y value is 1. So I'm going to do -3 times 1. And just so we show it step by step, this is my b, right? And then here, this is, I'm multiplying this b to this y. So then it should just look like this. Notice I'm doing -3, oh, sorry. I'm doing -3 times 1. And what is -3 times 1? This should just be 2 minus 3, and that's -1. So notice that this whole thing on the top becomes -1, okay? And now what I want you to do is just finish it for cx plus dy. What will it be? What is my c value? My c value is 3, so I'm going to do 3 times 1. And then what's my dy? My d is 2, and my y value is 1. So it's going to be 3 times 1 plus 2 times 1. Okay? So here, this is my cx. So it's 3 times x times 2, I'm sorry, plus 2 times 1. And notice that if we add this up, we get 5. This is a -1, sorry about that. And then notice that we get -1, comma 5. But doesn't this look very familiar, that this -1, comma 5, and it came all the way from this. Notice that when we did this matrix multiplication, I'm sorry, when we did this linear transformation, we got -1, 5. So then how do we get the same 2 answers for here and here? Notice that what does this 2, -3, 3, and 2 represent? They represent the coefficients of the x's and y's. So look at the coefficient for this 2x, it's 2. For this -3y, it's -3. For this 3x, it's 3. And for this 2, it's 2. Okay? So that's the connection for that. And what I'd like you to do is, let's try and just create a summary and closure using this idea of matrix multiplication. What I want you to do is try and multiply these matrices using this rhythm, right? Doing a times x, b times y, c times x plus d times y. And then just have this down, and then we'll go over it together. Okay?